Welcome to Creata classes. In this lecture, we will cover the perpendicular bisectors and the circumcircle. Okay, we have completed the medians and the angle bisectors. Side by side, we will compare median, angle bisectors and the perpendicular bisectors. This comparison is very must, otherwise you will be totally confused in the end. So with this lecture, we will compare the basic fundamentals of median, angle bisector and the perpendicular bisectors. Let's start with the lecture. Let's take a triangle ABC. This is the triangle ABC. We will try to draw the perpendicular bisectors in this triangle. First of all, let's mark the midpoint of the three sides of the triangle. Let's check the midpoint of BC as D, AB as E and AC as F. We have to draw the perpendicular bisector of the side BC. From the point D, we can form many bisectors for this side of the triangle BC. These all are the bisector of the side BC. Further, we have to draw the perpendicular bisector. So this line segment which is at 90 degree to the side BC is the perpendicular bisector. Similarly, we can draw the perpendicular bisector of AB. E is the midpoint and this line which is perpendicular to side AB is the perpendicular bisector. Similarly, we can draw the perpendicular bisector of side AC. Okay, F is the midpoint and this line segment is perpendicular to side AC. These are perpendicular lines as well as bisector of the three sides of the triangle. If we observe, these three perpendicular bisectors are also meeting at a common point. Let's denote this common point as O. This common point O is known as circumcenter. The intersection point of three perpendicular bisector of a triangle is circumcenter. This concept is in similar line with the concept of median and the angle bisector. Before moving further, let's compare this concept with the concept of median and the angle bisector. We know median is a line segment which joins the vertex with the midpoint of the opposite side. Here D, E and F are the three midpoints. So we got AD, CE and BE as the median for this triangle. While angle bisector are the line segment which divide the angle into two equal portions, that is they bisect the angle. Here these three line segments are the angle bisector for this triangle. If you observe, the medians intersect at a common point that is known as centroid, which is denoted by G. Similarly, the angle bisectors also meet at a common point that is in center. It is denoted as I. In the similar line, the perpendicular bisectors also meet at a common point. This point is known as circumcenter. So we can say centroids belong to median, incenter belong to the angle bisector and the circumcenter belongs to the perpendicular bisector. Got it? Side by side comparison of these three concepts are must, otherwise you will be confused in this lecture series. Moving further, let's come back to the concept of perpendicular bisector. Let's join the three vertex with the circumcenter, that is point O. We got the line segment AO, BO and CO. If we take these two triangles, that is triangle BOD and triangle COD, are you able to observe both of these triangles are congruent triangle? OD is equal to OD, that is common side. BD is equal to CD. Okay, D is the midpoint and OD is the bisector. And angle BDO is equal to angle CDO, that is equal to 90 degree. So by SAS, that is side angle side rule, we can say both of these triangles are congruent to each other. And by CPCT, we can say the corresponding sides of both of these triangles will be equal, that is BO is equal to CO. Okay, so we got BO is equal to CO. We can also got the same result, that is BO is equal to CO, through the perpendicular bisector theorem. This concept, that is the perpendicular bisector theorem, is not part of this lecture and we have just added it as an additional concept. You should know it. As per the perpendicular bisector theorem, if a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoint of the segment. Here OD is the perpendicular bisector and BC is the segment, and the point O will be equidistant from the end of the segment, that is point B and C. If we take any point on this perpendicular bisector, all these points will be equidistant from the point B and C. That is perpendicular bisector theorem. Just a small concept we have added, you should know it. Now coming back to the lecture where we have got BO is equal to CO, that is by congruency. Similarly, if we take these two triangles, that is triangle AOE and triangle BOE, here also these two triangles are congruent to each other. So by CPCT, we can say AO is equal to BO. Both of these line segments will be equal to each other. Similarly, if we take the triangle AOF and triangle COF, here also we got AO is equal to CO. If we compare all these three equations, we got AO is equal to BO is equal to CO. All these three line segments are equal to each other. In other words, we can say the point O is equidistant from the point A, B and C. OA is equal to OB is equal to OC. So we can say so. Are you able to correlate this wording with the concept of circle? That is, the center of the circle is equidistant from the points on the circumference of the circle. So with this same concept, can we draw a circle with center as O and OA, OB and OC as the radius of the circle? Okay, we got this circle with center as O and A, B and C are the 3 points on the circumference of the circle. Okay, got it? OA, OB and OC are the radius of the circle. This circle is known as circumcircle. The point O is the circumcenter and OA, OB and OC is the radius, that is circumradius for this circle. Got it? Okay, we have seen 3 concepts, that is circumcenter, circumcircle and circumradius. Are you able to compare this fundamental with the incircle? In circles, we have seen in the angle bisectors. The intersection point of 3 angle bisector is the incenter. And the radius of incircle is inradius. And incircle is inside the triangle and circumcircle is outside the triangle. Are you able to correlate both of these fundamental? Got it? Comparison is very important. Moving further, if we take out this circle and the 2 sides of the triangle AB and AC and the line segment OB and OC out of this figure, are you able to correlate this fundamental with the arcs of the circle? The fundamental is that the angle subtended by the arc at the center is twice the angle it subtends anywhere on the circumference of the circle. Here this arc is subtending the angle BOC at the center. O is the center, that is the circumcenter, and the same arc is subtending the angle BAC at the point A on the circumference of the circle. So as per the fundamental, can we say angle BOC is equal to twice of angle BAC? This is the formula, and this is very important formula. Direct questions are generally asked in the competitive exams. Again, I am comparing it with the incircles. In the incircles, we have done the fundamentals related to angle in the incircle as angle BIC is equal to 90 degree plus half of angle A. Here I is the incenter. And in the X circles, we have done angle BEC is equal to 90 degree minus half of angle A. We have done the comparison of angle, and this comparison is very important. We have compared incircles, X circles and the circumcircle. Got it? Our formula is angle BOC is equal to twice of angle A. Moving further, just now we have discussed the circumcircle, circumcenter and the circumradius. Now we will see the formula of circumradius. Here OA, OB and OC is the circumradius for this circle. Let's denote the circumradius as capital R. These 3 will be R. In the incircles, we have denoted the inradius as small r, and in the X circles, we have denoted the radius as R1. Now in the circumcircle, we have denoted the radius as capital R. The formula of inradius is R is equal to area of triangle upon the semi-perimeter of the triangle. And the X radius we have seen as the area of the triangle upon the semi-perimeter minus A. Now we will see the formula of circumradius. For that, let's denote the 3 sides of the triangle as A, B and C. The formula of circumradius is A into B into C upon 4 times the area of the triangle ABC. that is ABC upon 4 into delta. Here delta is the area of the triangle. This is the formula of circumradius. Let's see the proof of this formula. The proof is very small. Let's do the proof. Firstly, let's calculate the area of the triangle ABC. We know the formula of area of the triangle as half into B into C into sine A. Okay, this is the formula of area of the triangle. Further, just now we have seen angle BOC, that is this angle is equal to twice of angle A. So we got this angle as 2A. Further, just now we have proved that both of these triangles are congruent to each other, that is by SAS rule. So by CPCT we can say the corresponding angles will be equal to each other, means both of these angles will be equal to each other, and this total angle is 2A. So can we say both of these angles as A and A? We have divided the 2A into two equal parts, that is angle A and angle A. Further, if we take this triangle ODC out of the figure, this side is R, this is A by 2, okay, D is the midpoint, so we can say DC is equal to A by 2, half of the complete side A, and this angle is angle A, and angle D is a 90-degree angle. That is, the triangle ODC is a right angle triangle. Can we find the value of sine A from this figure? We will apply the basic formula of trigonometry, that is sine is equal to perpendicular over hypotenuse, that is sine A is equal to A by 2 upon R. Okay, A by 2 is the perpendicular which is opposite to angle A, and R is the hypotenuse which is opposite to 90-degree angle. This concept we have covered in the trigonometry. We got sine A is equal to A upon 2R. Let's put the value of sine A into the formula of area of the triangle. That is, area of triangle we have seen as half into B into C into sine A. On putting the value, we got area of triangle, that is delta, is equal to half into B into C into A upon 2R. On solving, we got delta is equal to ABC upon 4R. On simplifying, we got the value of R as ABC upon 4 delta. Okay, this is the proof of the formula of circumradius. Okay, we got the circumradius as ABC upon 4 times the area of the triangle, that is delta. Students, I have already told you the doing of the proof is very important. While doing the proofs, we got some concept and which can be used in the competitive exam in solving the questions. The concept that we have gained from this proof is that sine A is equal to A upon 2R. Similarly, we can say sine B is equal to B by 2R and sine C is equal to C upon 2R. If we calculate 2R from all these three equations, we got 2R is equal to A upon sine A, which is equal to B upon sine B, which is further equal to C upon sine C. Okay, this is also advanced formula of circumradius. If we know one side and the opposite angle, we can calculate the circumradius, that is R. So doing the proof is very important. We got some concept in between the proofs also. So don't miss the proof. You will not lose anything, just you will gain something. Okay, moving further. Before ending this lecture, let's take some additional concept related to circumcenter. We have learned that the meeting point of three perpendicular bisector is the circumcenter. Now the question is the circumcenter always lies inside the triangle, or it can be outside or on the boundary of the triangle? Let's see our different cases. In the first case, we will take the acute angle triangle, the triangle with the angles less than 90 degree. For this acute triangle, let's try to find the circumcenter. For that, let's draw the three perpendicular bisector of the three sides of the triangle. These three perpendicular bisectors are meeting at the point that is the circumcenter, and this circumcenter is inside the triangle. You can take any random acute angle triangle. The circumcenter will always lies inside the triangle only. Got it? Further, let's move to our second case, that is obtuse angle triangle, the triangle with one angle larger than 90 degree. Let's try to find the circumcenter for this triangle. For that, firstly let's draw the three perpendicular bisector for this triangle. Are you able to observe these three perpendicular bisectors are meeting outside the triangle? Means the circumcenter for this triangle is outside the triangle. So we can say it is possible to have the circumcenter inside as well as outside the triangle. Got it? You can take any random obtuse angle triangle. The circumcenter will always be outside the triangle. Got it? Now let's move to our next case, that is a right angle triangle. This concept is slightly tricky. Let's see. Right angle triangle is having two legs and one hypotenuse. Okay, here this is hypotenuse and these two sides are the legs for this triangle. First of all, let's try to make the perpendicular bisector of the hypotenuse. Okay, this line segment is the perpendicular bisector of the hypotenuse. This is the midpoint and this line segment is perpendicular to the hypotenuse. So this will be the perpendicular bisector. Further, let's draw the perpendicular bisector from these two legs of a right angle triangle. Are you able to observe these three line segments, that is these three perpendicular bisectors are meeting at the hypotenuse? And where on the hypotenuse? They are meeting on the midpoint of the hypotenuse, that is the starting point of the perpendicular bisector from the hypotenuse. Got it? So we can say the circumcenter, that is the meeting point of three perpendicular bisector for this right angle triangle, lies on the midpoint of the hypotenuse. So this is the fundamental for a right angle triangle. The circumcenter lies on the midpoint of the hypotenuse. You can take any right angle triangle, the circumcenter will always lie on the midpoint of the hypotenuse. Got the fundamental? Are you able to compare this fundamental with the fundamental that we have covered in the median? Are you able to remember in the medians we have covered the special case where we have covered the medians in a right angle triangle? There we have covered that in a right angle triangle, median to the hypotenuse is equal to half of the hypotenuse. Means for this figure, BD is the median that is connecting the hypotenuse. Medians are the line segment that start from the vertex of the triangle and that meets the midpoint of the opposite side. So this median BD is equal to half of the hypotenuse, that is half of AC. And D is the midpoint, so AD is equal to DC. So we got BD is equal to AD is equal to DC. So this concept we have already covered in the median. We can compare both of this concept. Both of this concept are exactly same. Okay, getting the point? The point D, that is midpoint of the hypotenuse, is the circumcenter. We can form a circumcircle from this point D as a center. This is the circumcircle that we can form. Slightly a tricky concept. Moving further. So we can say in case of acute angle triangle, the circumcenter will lie inside the triangle. In case of obtuse angle triangle, the circumcenter will lie outside the triangle. In case of right angle triangle, the circumcenter will lie on the midpoint of the hypotenuse, that is on the side of the triangle. Got it? Okay students, we have done with the perpendicular bisectors and the circumcircle. So these are the formulas that we have covered in this perpendicular bisector and the circumcircle. Again, no need to note down the formulas, just go to the download section and download all these formulas. So thank you very much for being with Creata classes. Bye for now.